Hi, this is Geometry, Topic 1, Foundations of Geometry. In this topic, our topic essential question would be, what are some of the fundamentals of geometry? So we'll start with setting a foundation for geometry and redefining the math terms that we already know, but in terms of geometry. So what is geometry? You'll wonder. We'll start that in a minute. Let's look at the topic overview. If you look at topic 1, there are 8 lessons total. We'll start with measuring segments and angles, basic constructions, midpoint and distance, inductive reasoning, conditional statements, deductive reasoning, writing proofs, and end with an indirect proof. So there are a lot of topic vocabularies. So starting with angle bisector, biconditional, conditional, conjecture, construction, contrapositive, converse, counterexample, deductive reasoning, inductive reasoning, inverse, law of detachment, law of syllogism, negation, proof, perpendicular bisector, postulate, theorem, truth table, and truth value. We have a lot. So it'll be a good idea to have a graphic organizer for you to organize all these vocabularies as we learn one by one. Yeah, this is a STEM project that you can apply what you learned in topic 1 and apply geometry fundamentals in Taj Mahal and see if you can see any rules. So let's start with lesson 1, measuring segments and angles. In this lesson, we'll be able to use properties of segments and angles to find their measures. Topic vocabularies are collinear points, line, plane, point, and postulate. Let's start with explore and reason. A teacher labels 2 points on the number line, A and B. So what are some methods for finding the distance between points A and B? How would you find the distance between point A and B? If you look at the picture, what is the girl doing? She is pointing at point A. So what do you think she's about to do? She might be counting how many they're apart by counting the tick points on the number line, right? So like 1, 2, 3, 4, 5, 6, 7, 8. They're 8 away, right? 8 distance away. What are other methods to figure out a distance? You can find the difference of the coordinates, 5 and -3. 5 minus -3 would be 5 plus 3, so you would have 8. And so there are 2 different ways to find the distance. So let's record that in your textbook. You can start at A or -3 and count the number of tick marks until you reach B or 5. Or find the difference of the coordinates 5 and -3. Okay? Part B. Which method of finding the distance is the best? Explain. So what is your favorite? Maybe the counting part is the favorite. Except, how do you count the decimals? Are you still accurate when you're counting decimals and fractions? Maybe not. So in order to be accurate, it'll be the best to find the difference of the coordinates, of the exact coordinates, if they are known, right? So you can have your own reasoning, but if you want to be exact, you want to find the difference of the exact coordinates. So let's choose find the difference of the coordinates would be the best for us. And let's say finding the difference of the coordinates is the best method because it will always, because it will always work no matter what kind of coordinates you are working with. Work, let's say, accurately. Okay. Topic essential question. Think about how the properties of segments and angles used to determine their measures would be, right? So we're gonna look at a lot of properties. Let's start with a concept. All right, the concept of undefined terms. Undefined terms are terms whose meanings are accepted without formal definition. So what do you know about defined terms? They could be defined, they could be explained, but undefined terms are meanings are accepted without formal definition in geometry. Okay? The terms point, line, and plane are undefined terms. We're gonna start with, we need to have some undefined terms to start with so that we don't have to prove from zero, right? There needs to be undefined terms that we could use to prove and define other vocabularies and concepts. So point, line, and plane are undefined terms that are the basic building blocks of geometry. It's very important. We're going to start building the concept of geometry and the rules starting from point, line, and plane. So let's see what they are. A point is a location that has no size. Okay, in the diagram, point P is an example. And notation would be P. A line is an infinite number of points on a straight path. So a line may look like something it's, that you've never realized it's just a combination of a lot of points, but it's not just a straight line. A line consists of infinitely many points. Just because you can draw a line quickly doesn't mean you don't have a lot of points on a line. Just remember that there are infinitely many points on a line, okay? And it needs to extend in two opposite directions. So you need to have two arrows on a line that is going either way, the opposite way. A plane is an infinite number of points and lines, not just points, also lines. So a plane consists of a lot of lines, and so it also makes it consisting of an infinitely many number of points. On a flat surface, which means it's not curved, it's not multiple layers, it's just a plane on a flat surface that extends without end and has no thickness, okay? So these are the diagram and notation for these terms. Let's look at the concepts, another concept. Defined terms. What are some defined terms then? In geometry, new terms are defined with using previously defined or known terms. A segment is a part of a line that consists of 2 points. So now we're using the undefined terms called points to define a segment. So a segment is defined by the undefined word points. Okay? Segment consists of 2 points called endpoints. They're endpoints because they give an ending to a line. So a line is a line extends forever to the opposite direction, but a segment has endings. So it doesn't have any arrows. It only has 2 endpoints. A ray has 1 endpoint and 1 arrow, but it's on a line. It's on the same line. Okay, it needs to have 1 endpoint and an arrow. Okay, and point and a side of the endpoint. Opposite rays are rays with the same endpoint that lie on the same line. So from T to S, it could be a ray. But from T to U, it's also another ray that's on the same line as U. So rays TS and TU are on the same line. An angle is formed by 2 rays with the same endpoint. Each ray is the side of the angle and the common endpoint is the vertex of the angle. So if they're on the straight line, if the rays are on the straight line, they're opposite rays. If the rays are not on the same line, but they do share the same endpoint, then they make an angle. Okay, so the angle here could be called by angle Q, or angle PQR, or angle 2. There are 3 different ways to label an angle like that. Okay, please take a note of that. Alright, so we defined some undefined and defined terms, right? Now, let's look at some examples to see how they are used. Example 1, the very first example of the foundation of geometry. Find segment lengths. How can you find the length of line CD? Okay, this notation is a line notation. So make sure you're used to some notation. Oh, it's a line segment. I'm sorry. So if you have 2 arrows on top, that's a line. If you don't have an arrow, that's a line segment. If you only have 1 arrow, that means your endpoint starts from M and your ray goes towards the other point N. Okay, so the order and the notation really matters. So for example 1, we have a line segment CD. We have 2 endpoints, C and D. How can you find the length of CD? So a distance or a length is always a positive real number. So you can use the number line to find the length of CD by either counting the tick points. They are 1, 2, 3 units away. Or you can find the difference. 4 minus 1 is positive 3. Okay? So the absolute value of their difference would also give them a distance. So to find the length of a segment, count the units of the length between the endpoints, or you can use the distance formula. So let's look at try it number 1. Now you try. Refer to the figure in example 1. How can you find the length of the line segment AC? See if you can solve by yourself. Come back when you're ready for an answer. Okay, are you ready? Yeah, so you're going to count from -3 to 0. 1, 2, 3. It's also 3 units away. Oh wait, it's from A to C. So 1, 2, 3, and 4. It's 4 units away. So you can either count or you can subtract 1 minus -3, and the absolute value of that would be 4. So, in other words, it's 4 units away. Or you can also write a notation saying AC is equal to 4. So if you see the line above AC, that refers to the line segment AC. If you don't see any line or anything above the points, then it's talking about the distance. So the distance between A and C would be 4. Okay, so those are the notation that you need to follow in geometry. You'll get used to it. Let's look at the next page. Postulate 1-1 is a ruler postulate. Every point on a line can be paired with a unique real number. This number is called the coordinate of the point. Okay? Every point on a line can be paired with a unique real number. So 3 is unique. 4 is unique on a real number. They're called the coordinates. The coordinate of x is 3. Coordinate of y is 7. The distance of the on a line. Distance between any 2 points, let's say x and y, is the absolute value of the difference of their coordinates. We just talked about it, right? So now it's an official concept that we looked at. So now we can use that to figure out the distance. So example 2 is finding the length of a segment. A postulate is a statement that is assumed to be true. So you'll use the ruler postulate 1-1, to find the coordinates of K and L. Because they're all unique coordinates on a number line, we can use the distance on a line to figure out the distance between the 2 points. So KL, the distance of KL would be 16 minus 12. The absolute value of that would be 4. Or you could switch the order. It doesn't matter which one you subtract first. Okay, so 12 minus 16 will give you a negative 4, but the absolute value of negative 4 is positive 4 anyway. So KL is either 12 minus 16 absolute value or 16 minus 12 and then absolute value, which will not change your answer, and it shouldn't. So the distance between those 2 points will be 4. All right, let's look at try number 2. Refer to the figure in example 2. What is the distance between JK and what is the distance between K and M? Figure this out by yourself. Come back when you're ready. Okay, are you ready? What is the distance between J, K using the postulate? So you need to use the formula. So you can either do 5 minus 12 absolute value or 12 minus 5 absolute value. It will be easier if you are not familiar with the negatives to subtract the smaller value from the bigger value. But either way should work because you have an absolute value. Right? So you should have an absolute value of 7, which is just 7. Or 5 minus 12, absolute value would be absolute value of 7 anyway, which is positive 7. Okay? So in the same way, what is B? Distance between K and M, 27 minus 12 would be 15, positive 15. Okay, so your answer is 7 and 15. Check your answer. Did you get it correct? If you did, good job. Postulate 1-2, segment addition postulate. Now, if points A, B, and C are on the same line with B between A and C, then AB plus BC is AC. What does that mean? Or if they're all on the same line, they should have a unique coordinate, right? And if we divide the segment AC into 2 parts, AB and BC, then if we add the distances between those 2 segments, then we should get the distance between A and C. Okay? That's called the segment addition postulate. It's postulate 1-2. So using that, let's look at example 3. We're going to use the segment addition postulate. Points F, G, and H are collinear What does collinear mean? Co means together, linear, line. So they're together on the line. Collinear points lie on the same line. So if GH is 16, so distance of GH is 16, what is FG? But they don't tell us the coordinates of FG and H. How do we figure it out? Well, we have the information that GH is 16, which is also represented by the expression 2x plus 2. So we know that 2x plus 2 must be 16. So 2x plus 2 is equal to 16. Solve the algebra, solve for x, subtract 2 on both sides, and you're going to divide 2 on both sides to get x is equal to 7. Now, because x is equal to 7, you do not have to solve for the entire formula, but you can figure out FH by adding the expressions. You know GH is 7, so you can just say GH, you know that GH is 16, so you can just add 16 plus 3 times 7 minus 1. Or what can you do? So you can either do, because this is equal to 7, you can add 7 plus 3x minus 1, where you know x is equal to 7. Oh, I'm so sorry, this is not 7. This is 16. So 16 plus 3x minus 1, where x is 7. You can figure that out and get 36 as well. But what are we doing here? We're applying the segment addition postulate and saying, and then we're adding the expressions together first. So 3x minus 1 plus 2x plus 2 will be 5x plus 1. If we add the like terms, 3x plus 2x is 5x, 2 minus 1 is 1. And then we know that x is 3. You can substitute that into your x and solve for the expression to get 36. So you can use method 1 or method 2, but you should get the same answer. Okay? It's the same logic. Alright, now it's your turn. Let's do try number 3. Points J, K, L are collinear, they're on the same line. If JL is equal to 25, what is N? What is JK and KL? Figure it out by yourself. Come back when you're ready for answers. Okay, are you ready? Yeah, so what do? First, what is the important information you have? If JL is 25, if the entire thing is 25, what is N? So you can add the expression by using the segment addition postulate, right? And say JL could be represented by the expression 3n plus 5n minus 7. And that, when you simplify the like terms, you get 3 plus 5, 8n minus 7. If you don't know how to add like terms, please go back to algebra in IXL and practice them skills and come back. And then you know that JL is 25. So say, substitute JL by 25, and then you're gonna solve for N. Add 7 on both sides, you get 32 is equal to 8N. And N is equal to 32 divided by 8, which is 4. Okay? So N is equal to 4 is the answer. What is JK? JK is 3N. So 3 times 4 is 12. 12. And KL is 5 times 4 minus 7 is 13. 20 minus 7. So that's 13. Okay? So N is 4, JK is 12, KL is 13. Alright, do it one by one, step by step, you'll get it eventually. Alright, postulate 1-3, protractor postulate. Given that a ray with the endpoint of B, and then the arrow is going to the A side, right? So starting from B, it's a ray. BA, and a point C not on BA, so it makes an angle. A unique real number from 0 to 180 can be assigned to BC. So that is called the protractor postulate. If we have two rays that are not on the same line, that are not opposite rays, then they could make an angle that are unique real number from 0 to 180. So 0 is assigned to BA, and 180 is assigned to BD, which is the opposite ray of BA. Okay? So this is called the protractor postulate that you're most familiar with by using the protractor itself, right? You already know how to use the protractor, but this is a postulate that explains and defines using the rays, okay? And real numbers. Okay, let's look at example 4. Use a protractor postulate to measure an angle. What is measure of angle BEC? BEC. So we're looking at this angle, BEC. Since EA lines up with 0 on the top scale, use the top scale for all of the other rays in the figure. By the protractor postulate, real numbers are assigned to EB and EC. So 47, if you look at this, you're going to start with 0, right? So you're going to look at the top numbers. And so that's a little bit over 45. And so it's 40. It could be 47, okay? If you have the protractor, it gives you more accurate tick marks than the textbook does. So it'll be more accurate. All right, and 105 is assigned to EC. So you can subtract AEB from AEC to find BEC, right? Because this is 47, and you know this, the entire angle from A to C, AEC is 105. You can subtract 105 and 47 to get the remaining angle, which is 58. Okay? So use a protractor postulate to figure out the angle that you need. So let's try number 4. Refer to the figure in example 4. We're going to figure out what the measure of angle AEC is, which we already did. And figure out the measure of angle BED. Alright, so if you can do it by yourself, come back when you're ready for answers. Okay, ready? What's AEC? We already talked about it. It should be 105. So yes, 105 is correct. What about BED? So if you figure out that AED is about, it's 130, then 130 minus 47 will give you BED, right? And that will be, that could be 83. So 83 would be a measure of angle BED. Alright, if you got them all correct, good job. Okay, postulate 1-4, angle addition postulate. If point D is in the interior, it means it's between, it's inside the angle. Interior of A, B, and C. Then measure of angle ABD plus DBC is equal to measure of angle ABC. It's very similar to the segment addition postulate. Basically, if your angle is divided into two parts with another ray, by another ray, then the parts of the angles will add up to the original angle or the bigger angle, okay? So if you have a ray that is inside the angle ABC, then if you add these two angles, it will be equal to the angle measure of ABC, okay? All right, application example 5. Use the angle addition postulate to solve problems. A lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees to the left or right from the shown starting position. Starting position is right here, which will be our end point. The beam of the light from the spotlight forms a 22 degrees angle. Can the designer use the spotlight to light each of the objects on the stage? So first, we're going to draw and label a diagram to represent the beam angle. So from the endpoint here, okay, the angles given and the unknown angles could be mapped with this diagram. Okay, the spotlight can rotate 25 degrees to the left or right from the shown starting position, which will be here. And then the beam of light from the spotlight forms a 22 degrees angle. So, you can use the angle addition postulate to find the angles the light must rotate to the left and right to light the chair table. So, from the starting point, x plus 22, which is, so x is this angle here, and y is this angle here that are unknown, and we want to know, right? 57 is from here to here, okay? 74 is the entire angle from here to here, and 22 is this angle in the middle, okay? And x is on the left of 22, y is on the right of 22. So write and solve equations to find x and y. So 57 minus 22 would be x, right? And y could be figured out by using the entire angle here. 74 minus 57 would be y. So using the known angles, we can figure out the missing angles, x and y. X is 35 and y is 17. So the spotlight can rotate 25 degrees to the right or left. So the designer can use the spotlight to light the table, but cannot light the chair. Okay? So let's refer to example 5 and try number 5. Can the lighting designer use a spotlight with a 33 degrees beam angle that can rotate 25 degrees to the left and right to light all of the objects on the stage? So what if the beam here is 25 degrees? So instead of 22, wait, 33. 33. So what if this is 33 degrees? And then we want to figure out the new x and y, right? The new x. Well, 74 and 57 doesn't change. So the new x would be 57 minus 33. And y would be 74 minus 57. Wait, and that doesn't change, right? Yeah, so x is gonna be different. X is gonna be 24 now, and y is gonna be 17, but they're both less than 25 degrees. So we can say yes. X is 24 degrees, and y is 17 degrees, which are both less than 25 degrees. Okay? Okay. Alright, I know this is a lot of concepts and examples for the first lesson, but this should be the last one. Okay, hold on. Okay, hang on. The last concept, congruent segment and congruent angles. Segments that have the same length are congruent segments. Okay, obviously. If they have the same distance, if they have the same length, they're called congruent. Okay? And you can use the notation of the tick marks. So if they have the same number of tick marks, so AB has 1 tick mark, CD has one, that means they're congruent segments. PQ has 2 tick marks, RS has 2 tick marks, so PQ is not congruent to CD, but PQ is congruent to RS. Okay? Angles that have the same measures are congruent angles as well. So you can use the number of arc marks to show congruent angles. So the angle U and Y has 1 arc mark, so they're congruent angles. G and K have 2 arc marks, and they're congruent. But you know that U and G are not congruent. Okay? So some properties of equality have equivalent versions for congruence. We have some important and basic properties. Reflexive property of congruence, symmetric, and transitive. They always come out in the future. So you should know, you should get familiar with reflexive, symmetric, and transitive property. It will come out for equality too, for similarity. Yeah. So it's gonna come up a lot in the future. So reflexive is when we say when the lines are congruent to each other, or when the angles are congruent to each other. It's obvious that it should be congruent to itself, but there needs to be a property for that, so that you can reason out while trying to describe other properties. So obviously AB is congruent to itself. Angle A is congruent to angle A itself. Okay, symmetric property is when so for example, if AB, line segment AB and CD are congruent, then CD and AB are congruent. So if you switch the order of congruent statement, it should still be congruent. It shouldn't change a thing. So if angles A and B are congruent, then B and A are congruent too. Okay? You just switch the order. That is symmetric. Transitive is when you have 3 different things in a statement. Okay? So if AB and CD are congruent, and CD and EF are congruent, they're both congruent to the same line. So AB and EF must also be congruent. Okay? That's a transitive statement. A and B, angles A and B are congruent and B and C are congruent, then angles A and C must be congruent. Alright, so thinking about that, let's use that as example 6. Use congruent angles and congruent segments. So part A, if measure of angle XWZ is 127, the whole angle is 127, what is measure of angle YWV? We know that angle XWY is 32. We know that XWY plus YWV plus VWZ is equal to XWZ. I'm not sure why the 127 is not shown. Oh, it's here. So if xwz, the whole thing, is 127. What is ywv? But what do you think is missing? Aren't we missing the angle here? In order to get the angle here in the middle, we're supposed to subtract these two angles, but this angle is not given. How do you figure it out? Well, do you remember the notation for congruent angles? We mark them with the tick arc. So now, if you look at this, you have one tick arc here, you have another arc here. That means they're congruent. So this also must be 32 degrees. Does that make sense? Yeah. So 127 minus 32 is 63. And that is the measure of angle YWV. Okay. So part B, what is HF? What is the distance of HF? Okay, the entire distance on the bottom here. HF is equal to HG plus GF. And HF could also be rewritten as AH because you see these two tick marks, right? It means they're congruent. So that's also 11 centimeters, right? Plus BC, because you see a tick mark here, a tick mark here. So that means they're congruent, and this is 8 centimeters. So HF is equal to 11 plus 8, which is 19. Okay, so use these properties all together, and you can figure it out. Let's try number 6. See if you can do it by yourself. 6a, if measure of angle NOP is equal to 31, measure of angle NOQ is 114. What is measure of angle ROQ? See if you can do it by yourself. In the figure in part B above, suppose CD here is 11.5 and DE is 5.7. And the perimeter, the entire measure around the figure, is 73.8. So what is GE? So pause the video, see if you can figure it out by yourself. Come back when you're ready for answers. Okay, are you ready? Let's start with checking the answer for part A. If NOP is 31 and NOQ, the entire NOQ is 114, what is ROQ? We know that POR should be equal to ROQ because they have the same number of tick marks, right? So then you can say that measure of angle NOQ is equal to measure of angle NOP plus measure of angle POR plus measure of angle ROQ. But then POR and ROQ are the same angle. So you can say measure of angle NOP plus 2 times anything, measure of angle, either angle, let's say ROQ. And so you can say NOQ is known, 114, and NOP is also known, and then you don't know measure of angle ROQ, right? That's the angle measure that you need. So then you solve it. 114 minus 31 is going to be 83, right? And that's 2 times measure of angle ROQ. And so measure of angle ROQ is 83 divided by 2, which is simply 41.5. So the answer is 41.5. All right, what about GE? All right, you know that the perimeter is the distance around the whole figure. So if you know the distance around the whole figure, perimeter, is 73.8, what are the known distances? You know that HF from the example shown before is 19. So you're just going to subtract all of that. Or you can say, let's write one by one. You know that the figure, the perimeter, is equal to AB plus BC plus CD plus DF plus HF plus AH, right? And then you know that perimeter is 73.8. You know AB is equal to the 3 tick marks here. Have you figured that out? No. So that's fine. We want to figure out GE. GE is equal to AB. So if we figure out AB, that's like figuring out our answer. GE is equal to AB. Okay? Plus BC is 8. CD is 11.5. DF is 5.3 plus EF, which is 8. Right? Because it's the same as GF. Yeah, and BC. Okay, so 8 plus HF, which is 19, plus AH, which is 11. And then we just have to subtract everything here from 73.8 to get AB. And if you do that, AB will be 11 centimeters. So AB is equal to GE, so G is equal to 11 centimeters. And the answer is 11 centimeters. Okay, did you all figure it out? So answer for part A is 41.5. Answer for part B is 11 centimeters. Okay, if you got everything correct so far, great job. Congratulations on finishing lesson 1 of topic 1. Yeah, that's a big step. So let's summarize our lesson. Measuring segments and angles. So there were a lot of postulates and definitions. These are only 2, but I recommend going back and getting familiar with all the notations and the rules. But basically, a ruler postulate says that every point on a line can be paired with a unique real number. So you can use this to find distances between the coordinates. Protractor postulate also says that given 2 rays that are not on the same line, or they're not opposite rays, they have a unique real number assigned from 0 to 180. Okay? So remember these postulates, and if you have any more questions, please feel free to ask Ms. King in class. Otherwise, we'll continue with the next lesson in the next video. Thanks. Bye!